Secretly recorded from deep inside the bowels of a decommissioned missile silo, we bring you the man, one single man who wants to bring light to the darkness and dark to the lightness. Although he's not always right, he is always certain. So now, with security protocols in place, the protesters have been forced back behind the barricades and the blast doors are now sealed. Without further delay, let me introduce you to the host of HuttCast, Mr. Tim Huttner.
Thank you, Sergeant-at-Arms. You can now take your post. Today on HuttCast, we have Ron Flood from Cedar Machine. Ron, we are going to talk about what tonight?
I think we're going to just basically start from the bottom and work our way up on, let's just say, engine block tonight. Engine block work and the different qualifications and machining procedures, and kind of see where it goes from there.
Okay, you heard Ron. This is my intro, and we're going to be back in just a moment with HuttCast and Ron Flood from Cedar Machine. Stand by. Now a word from our sponsors. Today's sponsor in part by Excel Roofing. Excel Roofing, they do it all. Roofs, siding, framing. You need a house? Give Excel a call. I've used these guys personally in the past, have a professional crew, they're conscious of your job, and they want to produce the finest quality of craftsmanship available. Excel Roofing, 763-712-0757. Again, 763-712-0757. Excel Roofing, Dayton, Minnesota. All right, we're back in studio. Well, actually, in virtual studio. We have Ron Flood from Cedar Machine. And let's have a discussion, Ron, about blocks. And I want to thank you for coming back. We have a lot of listeners that have moved your show to the number one position on HuttCast, which is kind of cool. And they want to hear more of you. So, Ron, let's talk engine block.
Well, there's a couple different ways to go about. Let's say you're going to build an engine. You have to decide ultimately what your goal is first, and then from there you got to decide is it best for you to go with an aftermarket block or to rework a stock block. And sometimes you got to look a little bit into the future on it. I mean, if you're going to build a 600 horse big block Chevy and you're going to build a mild type of deal where you're going to use it for street strip application, but you may decide, somewhere down the line, and, you may know yourself that you're going to say, well, at some point I'm going to put bigger heads on this. I'm going to jack up the compression. I'm going to, add a bigger roller cam, make more power. It might be good at that point in time to kind of overbuild your bottom end so that it'll accommodate, your future needs out of the engine.
Okay.
That's not. Well, go ahead.
Let's do it. Let's do a different version here. I walk into my engine builder, and my engine builder is going to, of course, talk to you. I want to build, let's say we want to build a mud truck that runs consistently, high compression, high power, high alky, and you want a lot of torque, a lot of cubes. Which way are you going to point them? Stock block or aftermarket? Well, or I say no.
Then you're going aftermarket block. Anytime you're going to go, aftermarket being like a bow tie or a dart or a world or something like that, keep black. And the reason is because most of your stock blocks, your bore is going to cap you about 4.375 on, say, a big block Chevy, or like a small block, 4.060 on a 350 base block. It's about all the bigger you're going to get. So the aftermarket block totally opens up the bore for you. And then the bottom end is, of course, a lot stronger. There's a lot of things you would have to do to a stock block, filling the block, putting billet main caps on it, things like that, to even get it close to being as strong as an aftermarket one. So on some max effort, you're going to default to an aftermarket block.
Now
they still need a lot of machine work too.
Oh yeah,
yeah. It's the cost at the end of the day is naturally going to be higher, but I think the aftermarket blocks you've got. I think from a resale standpoint, they hold their value a little better. And then, of course, when you in the future decide you want to now take your alcohol engine and put a supercharger on it or big nitrous or something, you've got the foundation there. So that's always a good choice.
Okay. Now I dropped off 632, not world blocks. What are those?
Dart.
Darts.
Dart Pro, 2 Sportsmans and 1 Pro Series.
Okay, Pro Series has the billet mains.
Yes.
All right, so those motors there, what are you seeing on those as you're going through those?
Oddly enough, it's almost like we saw a little bit of a progression in Dart, because one of the Sportsman blocks has the shorter cast lifter bores, and the next one, the bore is a little beefier, and there was a few differences on the actual machining of them. So I'm not really sure, just relieving for the push rod area where we go down and bore for the lifter bore and everything. I had to do some counter boring on one that I didn't on the other. So
Really?
there was kind of some differences on them. And then the Pro Series block, of course, having the billet caps on it, but they generally give you a little room to do some finesse work. The main bores, when we put studs in and torque cycle them, we have to then finish home those, bring them back out to the mid spec. And, of course, the decks are just a rough, it's not a finished machine deck. It's not to height.
Right.
And they're not perfect. It's, you're buying a core block with the primary locations in place. The cam tunnels, generally within a couple thousandths, which is really good. That seems to kind of be a working tolerance on some of these aftermarket blocks, and maybe within 3 thousandths on the cam tunnel. As far as kick and sway, center to center, they seem to do a pretty good job on that. I will say that. So unless we're going to a larger cam core, like a 55 mil or something, the cam tunnels are generally good. Lifter bores, they can be off a little bit. I measured one of yours. A guy asked about it because I had posted a video, and I checked a couple, and they were, about 12th indicator reading. So that's showing about a 6,000ths out of position from center line as far as lifter bores. But again, it's a production tolerance, and it's an 842 lifter bore. And, if it's a real performance engine, a higher end performance engine with bigger spring pressures and everything higher up here, you're going to put a bigger bodied lifter in it anyway in a bushing. So we just look at those 842 lifter boards as an access hole to tool, to get a tooling through.
Oh, I see. We landed 904s on that, is that right?
Yeah, 904s with a full-time oiling that goes around the bushing instead of from one end to the other.
Okay, so go ahead.
That could be a problem with some of them. The lifter on some of them, at max lift, will actually cut the oiling off all the way down the line for a moment while it's at max lift. So when we bush them and put full-time oiling in them, it's always putting pressure to that lifter bore.
Okay. And when you cut a lifter bore, what's the thickness of the bushing?
It's a 1-inch bushing OD, and then the ID, it's either going to be a 904, which gives you around 50 wall, or an 875. Just depends on which block it is. Some of the rule legal stuff we have to still do 842. So,
I see.
Anything bigger than a 904, then we go to a 937 would be a 1060 bushing, because that allows us some real estate on the backside to put the oiling groove in it.
Now these 3 motors are, of course, from our shop. We brought them up to you guys to give you their kung fu. What I'm seeing is they weren't a raised cam, so at that point you eliminate 632 6 on 700 on 4600, because you can't swing the rod enough to clear the bottom of the lobes of the cam because it's not high enough. Therefore, we can't go to a 55 mil. So what we ended up doing was we kind of had a workaround, and we did Howard's cams, built us some full billet cams.
Yep.
And it's the toughest stuff we can put in there in that height. So literally, that's all we're doing. We can't get any more out of it. What are you seeing for the datum on your cam journals? Were they straight all the way back?
As far as location, I believe one of them was within 2 thou, and the other one was within 1.
No, geez.
And I can't remember. I wrote it on the blocks, but they were within 1 and 2 as far as the kick and the sway. And I don't actually, what I do is I just do a quick measurement on center to center on that from the ends. And then when it's actually in my machine where I do the lifter bores, I can tram both sides of it and determine if the cam tunnel is crooked that way. I can actually do it with a block truing fixture too. If you have a deck squared block to take that fixture and move it from the front to the back. But I can see right in my cam tunnel fixture when I go and tram each side, because I've got datum surfaces on each side, and we reference the plates on the front and rear, which are located off of the crank and cam center line. and I can tell which way the cam is kicked just by tramming those. So
Oh, wow.
they were within one and two. So I mean, that's very close. That's that's as close as you're going to get. I mean, we can nail them to absolute zero by when we line bore them and locate them or increase the size. But I mean, we're probably putting a lot more time into it than they might on a production line. So.
Sure. And because of the motor twist and everything starts to wind up and you're putting that whole engine block under load, they're going to change as well as they're moving, right?
Yeah, I mean, there's probably a certain amount of the actual camshaft twist from front to rear too. I mean, I know that I've heard of some cam grinders actually grinding some advance into the lobes as it goes down the shaft because of the twist in the camshaft.
Uh-huh.
So they'll, where from the absolute front to the absolute rear, they might get, X amount of degrees of deflection or rotational twist, torsional twist. So, but that's the idea of the bigger core, is that you're trying to mitigate that by just flat out having a bigger, beefier cam in there.
But again, if you can't get that raised cam off of the crank center, then that's all you can do is run what you can run. Right.
And you're limited, on some of the stuff, you can't really run a 4 3/4 stroke with an aluminum rod. It's just, you don't have the real estate in there to do it.
Yeah.
So it limits a few things, going with 4.5 inch. Some of the 582 combinations they're really popular because they like to spin a little more RPM with them. And if you're making boost, you're primarily making your power off boost per se,
Mm-hmm.
So more than cubic inches, especially when you get into stuff that's 40, 50, 60 pounds of boost. There's guys doing it with 540s. So they're making, I have a friend actually, Chris at CNS Automotive. He races, does that small tire or the 10.5 stuff.
Okay.
And that thing makes between 2,500 and 3,000 horsepower, depending on how much boost he cranks to it. And that's just a conventional head 540.
Oh boy.
But he's running a Pro Charger on it that's spinning a lot of overdrive. And, those things are purely making power off boost, not cubic inches.
Right.
So,
well, whatever it takes to stay consistent, right?
You got to fill a cylinder and pack it full of pressure.
So those blocks that we're on right now, the 3632s, have you had a chance to check square deck on them?
Yeah, they were, let's see, we did tram them and we did actually make a video on them.
Oh, okay. And that video can be seen where?
That's on the Facebook page for Cedar Machine Service, where I kind of go through and we've got it on the machine, and like one side was off from 5 thou left to right. It was passenger side front to passenger side rear was off like 5 thou. And then the driver's side was dead on. And then as far as the exact 45-degree index from crankshaft to camshaft center line, which is what our fixture goes off of, they were, off of 3 thousandths or something.
And tell everybody the importance of having a equally decked motor, because you got equal rods, you got equal pistons, you got everything else is there. But if you have one half your motor 5 thousandths up on the other, tell them what that will do.
Well, it changes the quench. It's going to change, the tune-up of the engine, as far as the timing. Well, you know about that. That's, your fuel injection and timing system.
Mm-hmm.
If you've got, 40 thou quench on one side and 50 on the other, say, it's going to require different timing. It does change the dynamic of it. And that's where cylinder to cylinder index becomes important too, because if you've got a cylinder that's, out of alignment with the rest of them and it reaches top dead center sooner than the one next to it, you become kind of a slave to the worst cylinder in the engine,
Yep. You're only as strong as your weakest cylinder.
And so, getting back to the blueprinting thing, and there's a lot of ways to do it. There's manual machines or CNC machines. I mean, you could literally blueprint an engine on probably, if it was a good machine, on a 70-year-old milling machine with manual data and using the readouts on the cranks. I mean, you could do it if you had all the blueprint locations and everything. We do everything manually, but with blueprint tooling, which is kind of a bridge between doing it manually and doing it on a CNC, because you actually have the tooling which does the alignment and everything for you, like with our cam tunnels and stuff. We don't have to go and calculate a lot of stuff. It's a fixture that goes off the mains. Everything starts at the mains. The main line of the engine, that's your basic starting point.
That's the authority.
No matter what it is.
Yep.
And after you do the mains, you got to do the cam tunnel. And the reason for there is that our fixturing and even fixturing on like a CNC machine might locate off the front, a main datum bar and a spud that goes into the front cam bore. So the cam tunnel's got to be aligned and corrected as well, because then the fixture that cuts the deck is cut off of that. And our fixturing for indexing bores uses that deck as a reference. So you'll see sometimes where a guy who may not have indexing equipment or something might actually bore and hone a block so that he can pre-assemble it to calculate deck heights or measure deck heights to know how much to deck the block. And the biggest fundamental problem with that is usually a shop that may or may not have those blueprint fixtures. Well, they might bore that block off of that deck as crooked and out of line. So now you've got crooked cylinders that you're trying to, pull measurements off of. So it becomes a compound of inaccuracy. It's now cylinders are wrong because things were done out of order. So,
well, go ahead.
I don't think a CNC machine would care what order you did the decks or the lifter bores or the bores, because it's going to go off that measurement of the cam tunnel and the crank center line and pull references off of that. But the way we do things in a lot of shops that do it manually do, really rely on that deck surface as a datum surface. That's a datum surface pulled off of the crank center line and cam center line, and now we locate bores off of it. So, lifter bores, of course, the way we do them with the fixtured tooling, and a lot of people do, if that cam tunnel's not straight, now the lifter bores aren't going to be to a blueprint location. Well, they are going to be to the cam. They might not be, from the front to the rear of the engine as far as the crank. So let's say the cam is kicked 10 thousandths from front to rear.
Okay.
The blueprint type fixture tooling will make it so that the lifter follows that cam. A CNC machine may just go from the front and pull a location and go all the way to the back. Now, if the cam runs away from those lifter locations because they haven't, used the front and the rear of the cam to pull a reference off of, that might actually be a situation. I've seen some that they only do pull off the front and not the rear. So that could be a situation where if that cam tunnel were off, your lifter bores and your cam could be out. So that's where the fixturing, if a cam tunnel was off, 2 thou from center line one way or the other, using the fixture, at least the lifter is going to follow that camshaft. Your timing events are not going to be hindered. So. And
if you time, like we time off a crank, so we are every 6 degrees times 720. So when our timing is on and it's pretty accurate, the last thing you want to do is be chasing around that quench on a cylinder that's pushing a lifter on the wrong side.
Well, or the fact that if the lifter and cam are not actually indexed and blueprinted and the timing events aren't happening correctly, you might have a cam, say, swings off to the left in the block and a lifter location that follows the same center line as, say, the crank or the bores. And now as your timing events go from the back of the engine, your valve timing events, they get later and later because the camshaft is farther and farther away from the lifter. And of course, when you open it later, you close it later. And so
you're losing power.
Now your cylinder pressure will change with each one too. I mean, it would have to be a lot to be a huge difference. But that said, I've seen some blocks, particularly, there was some Mopar blocks that were sourced, aftermarket Hemi stuff that were sourced through several different manufacturers or, job shops.
Yeah.
And I had one that the cam tunnel was off 25 thou. We had to put a 55 mil roller. The cam tunnel was so far off.
So could you clear rods at that?
They got a lot of room. The cam's way up in there.
Oh, I see.
It's a 10.7 deck. So that's
geez. 10.7, yeah. Those 632s are 10.2s.
Yeah. But, yeah, there's all kinds of room. Well, actually, trying to think, the big block Mopar and a big block Chevy, though, might have the same crank and cam center. But this stuff's all 4.5 inch bore, or 4.5 inch stroke, so.
I see.
But I actually think the Chevy and the Mopar have the same crank center line. I'd have to look again on that.
Well,
let's talk. A lot of them share the same one.
Oh, I see. And let's talk a little bit about materials for a block. Back in the old days, they used to take a block. I know Mercedes did. They'd throw a bunch of them, build a bunch of them, throw them in a cave for 10 years, and then bring them out, and that's their sitting. They're aging the block. Seasoning, yes.
Seasoning, yeah. That's what Buick would do too, allegedly.
Is that right?
Yeah, that's what I had always heard, that they poured the blocks, and that's why the date codes are earlier than the cars or whatever, and they put them out in the yard until they machined them. Supposedly they were seasoned. That was a big deal. Seasoned being it was left all winter long until the next year's production.
Was that right? Not 10 years, but 1 year.
Yep, just a year.
Okay. What do you think about seasoning?
Well, I certainly think that when you take a brand new engine block, and we've seen this before, on its very first build, you can run it, dyno it, makes power, whatever. It always seems like, even if you were to just dyno it and make a dozen pulls on it, if you were to disassemble it, go through it, things move around, especially like cylinder heads. That's why we take them, throw them to an oven and try to at least get some of the stresses out of there from where the seats are pressed in and everything. But, I'm telling you, it seems like that first freshen up is when the engine makes the best power it ever will. I mean, all things being the same, as long as you don't change ports or change cam or something like that. But
sure, it
just seems like you get a better ring seal, and everything is now kind of stabilized.
So how would that equate to let's say a Donovan or a New Process?
New Century.
New Century, yeah, run up his blocks.
Well, any aluminum block now with the sleeves in them, there's kind of a lot of stresses in there from the manufacturing, from the sleeves being installed, and they heat the block up with the sleeves and shrink it down. That's definitely, I would say aluminum blocks are probably even worse as far as, things migrating around. We've had aluminum blocks to where we've, started out like, say, just a big block Chrysler or something, and bored and honed it and done all the machine work, and it come back for a freshen up or whatever, and we go to hone it, and there's like little shadows where it's not hitting here and there. It's like, well, we know it hit before because we started with 5,000 hone, but
right.
Granted, we're not taking a ton of material out, but you see where the sleeves have kind of moved around on the deck. They pushed around a little bit, because if there's press fit on a ductile sleeve into aluminum, that ductile sleeve is going to win that battle over time.
Oh, for sure.
I mean, it's going to heat and cool, and they go out around a little bit, which is why a lot of times we'll leave a little gap between the sleeves on the top to let them do that a little.
Okay.
The sleeves have flats between them on some, so you'll generally see a small gap between those.
Yeah. My 632 New Century has got flats on in between the two. It's not O-ringed, but they're there.
Yep, and you'll see a slight gap there.
Yes. All right, so we've covered that. All right, I gave you the scenario of the first engine. Now this guy, let's shift gears. The World Block has been a lot for roundy guys, and those guys, they're wide open, wide off it, wide open, and it's all night. That's all they do. They zing up, zing down. What block would you put them in? Would you say aluminum versus cast iron with a 5% nickel rating?
Or in what application? For circle track?
Roundy guys, yeah. Circle track.
I don't know. There's not a ton of the classes that we see, as far as the modifieds and stuff like that, they'll even let you use an aftermarket block, I think, isn't until you get to like the late models and things. I know that a lot of the lower classes, they have to use an OEM block, but I think really with circle track, where it amounts to is the guys are just looking for the lightest block they can find, because they'd just rather be able to put the weight wherever they want to put it, not where it just ends up because of, happenstance. I know that World used to make it was a really nice small block, and we used one once, but it was like 210 pounds. I mean, it was an incredibly heavy block. I mean, it was a beast, and it was strong, but it was real heavy. So that's something to where you got to take that into consideration. It depends on the horsepower level. I mean, those engines, an SHP block, a Dart SHP, that's probably going to be able to handle the kind of horsepower that, say, a late model or an A modified would put out. It's, those things might make, 750 horse or something. And that block is good for 800 horse. And, I wouldn't see any problem with that. And the nice thing about it is a little bit lighter, but when you get into some of those Pro Series blocks, they're a bit heavier. It's, it's no joke. We get blocks from a guy in New York, and he hasn't run, they're Dart blocks, and he hasn't run through a lightning program that a guy does. And they literally scallop the main caps, everything. They take like 40 some pounds out of these Dart blocks. Now, the thing is, it's an asphalt super modified, and they're restricted to like, I don't know what the size is, like maybe 480 cubic inches or something. So it's a 4-inch 310 bore. So it's a ton of bore in that motor as far as the material. It's a small bore, a lot of material. So that block is even heavier than, 4.5 inch or 4.6 inch bore. So the lightning program is almost, mandatory.
Yeah, critical.
You're starting to get into something like that. My thoughts have always been, because, we like Nicocil. We don't mind Nicocil and aluminum. I always thought for something like that. I mean, they make, 800 or 900 horsepower. They spin them hard. They're spinning them 9,000 plus. But I always thought, man, you could bore that block out or take a totally worn out 4.6 inch bore block, sleeve it back down with aluminum sleeves with Nicocil, and that would be a great way to take weight out of it. But I've never got anyone to take me up on that yet because I think it would be pretty expensive. I had one guy down south that wanted to do it with a 400. He's like, well, should I just buy a brand new, dart block? I said, no, go out and buy a totally worn out one. We're going to bore it out anyway.
Right. Well, so if you're out there listening, give Ron a holler if you want to take that experiment. He's up to doing that. It sounds like. Yeah,
it would be very interesting, because I think you could do it, and probably take the weight out without at all, structurally impeding the block. It's
okay. That's something for the listeners to review.
Going back to that bore size, so. Yeah, there's a lot of stuff like that. I'm sure someone's tried it and probably haven't heard of it because either it worked and they don't want you to know, or it didn't work at all and they didn't want to admit their failure. So,
kind of how it happens.
Transparent than that. I'd try it and let everyone know what happened. I don't care.
All right, we are 25 minutes into this first segment. What we're going to do is I got to take a break for some sponsors, and let's talk about UTI when we come back. Let's talk about ultrasonic, and we'll just kind of brief on what we got here. So, Ron, stand by. Everybody, HuttCast will be back in just a moment. We hear a lot about air quality these days, so keeping your indoor equipment running clean and efficiently is important to your health. The experts at Dependable Heating and Cooling in Coon Rapids have been servicing the Twin Cities areas for more than 25 years. With the latest and most efficient technology available, they will repair or replace your equipment and keep your indoor air healthy and comfortable. Call 763-757-5040. Our team of experts is standing by, waiting to help you with all your indoor needs. Mention you've heard about this by listening to the HuttCast podcast, and you will receive a $50 off any repair. That's Dependable Heating and Cooling. 763-757-5040. Dependable Heating and Cooling. Welcome back to HuttCast. Again today on the virtual line, we've got Ron Flood from Cedar Machine. Minneapolis version of Cedar Machine is on the hook, and he's telling us about engine blocks and what he's seeing. So, Ron, we left the last segment. We were going to discuss core shift. We're using our UTI, our ultrasonic testers. Tell me what you want people to know about that.
Well, the core shift is kind of a funny thing. A lot of people want to admit that it happens, but they want to also take a look at a block and say, well, this one's good because my cam tunnel seems centered on the thrust pad, or the number of this block is good, so they're all good. And, my opinion, and I tell people this all the time, regardless of, whatever the block is, I mean, Mopar, some of them have visibly different main webbing and things, but when you're talking like a big block shaft, let's just say it's big block Chevy factory block, and guys will say, well, this XYZ number is the best one. And, my response to that is, it's not unless you sonic test it. I mean, just because it's known to be one of the better blocks doesn't mean that one is good. The only number that really matters is the reading on the actual ultrasonic tester readout screen.
Right.
So
the equipment is king.
Yeah, and there's a lot of reasons why that's important. We actually do on all of the stock blocks that we do. It doesn't matter what it is. We do a 4-point inspection, which is midway through the bore in just 4 locations. And the reason is, if we're going to bore a block, say 60 over, if we're going to index that block, we need to know that our index fixture isn't telling us to move a bore into the major thrust location where it's already thin. Sometimes you have to make compromises. You can't just pick up 30 thou of location and make a block already thinner on the thrust side, because common sense has to say that's not a good idea. I have to give up some location on this one because at the end of the day, the thickness is going to overrule the location. So that's where we end up with on sonic data a lot. I mean, it's valuable. Sometimes it tells you that you're okay. We just had a block last week, and it was a small block, and it was very thick on the thrust sides, or on it was the driver's side valley, so where the thrust side of the bore is.
Okay.
And it was like 270 thou thick.
Oh.
And we're boring at 60 over, and we literally had to move these bores 45 thou. And the only reason we didn't move them more, they were actually 60 thousandths out of alignment. And we had to move them 45 thou because that's just as far as we could go and still have material to hone, and make the cylinder straight and round. So, if we would have just bored that block, I mean, my gosh, the whole bank was 60,000 south. So can you imagine doing the timing on number one?
Mm-hmm.
The cylinders all being moved to the right, so the top dead center occurs later. And then where's the timing going to be on the passenger side bank? So,
right. And if you're crank turbine, remember, we're every 2 to 6 degrees.
Yeah. So, and that one, and I had a big block Chevy one. It's one of my own personal blocks, and it was a 289 big block shout. And from the rear to the front, they were off 50 thou. I mean, it just progressively worse from, the front was off, and then it got better toward the rear. But, from the factory, they're using those 2 gang plugs on the bottom to locate the block, and they go in and they shoot the bores in. Well, if that gang plug isn't perfectly situated, if they didn't machine that to begin with perfect,
right,
every machining operation from there is going to be off. So, I mean, they might be correct to each other, but not correct to the actual core as it was cast. So that's where we would see, real inordinate bore thicknesses. And a lot of times it's, it goes the other way where you have one that isn't that far off, but the cylinder is, 100 thou on one side and 220 on the other. And it's just because when they placed that, the inner and the outer core, all the mold pieces together and poured the metal, it was just off,
Sure.
So
I believe when we did the ring pull motor for our research and development on our ring tool, that Chrysler had 187, and on the other side it was 220 on core shift, and that was driver's side. Yep. So that kind of caught me off guard. The passenger side was fine, but the driver's on this one was off, and that was a 400 low deck Chrysler with program main caps, so a lot of the good equipment. And this was before I knew you, but that's all we could do with it. And it was ran on a CNC, and they corrected that.
Right.
So I'm sorry, Ron.
It just had core shift in the block if the locations are right.
Old school 400, 70s block, 5% nickel deal. I mean, that's all we could get out of it.
Right.
So are you seeing more of a core shift with factory blocks or OE blocks, hot rod blocks, Dart, etc.?
Well, no, the aftermarket blocks are definitely better. Yes, I have seen issues with like the Mopar Performance. They had number one cylinder. You got to be super careful with that. And I've had to do it on 2 or 3 different Hemis to where I couldn't index that cylinder exactly perfect because the driver's side number one cylinder on the inside, the thrust side, was just getting down. It would have been 140 thou thick. It was just, and I've seen it like 3 times. So I don't know if it was a mold issue or whatever, but that was one in particular. Buick, number 6 cylinder. You got to check the major thrust, which is the outside of the cylinder wall. But front to back, they get really thin there too. And the front side of number 6 cylinder on a Buick is, and this is 50-year-old engine blocks, but it's just kind of a known thing that if we're going to qualify one of those blocks, I just have to check that cylinder first. And if that thing passes, 99% of the time, all the other 7 are going to be fine too. So you kind of get to know the nuances of each individual block and the engine families. Some of these things that guys have come up with, like looking at the cam tunnel and determine if the core shift is off that way. I mean, it's valid, but it's not an end all. It's not because the cam tunnel is off, it's no good. Because I've seen some where the cam tunnel was not centered, as far as on that thrust surface on the front, but the sonic check was fine. So it's not an end all until you put that gauge to it.
Now, some of the old 455s, the BOP blocks, they would lose oil in on number 7, 8 main journals, and they were already trued up in the machines. So what do you equate the number 7, 8 cylinders losing rod pressure on the oiling to squaring up the block?
Oh, that I don't know, because I've always thought that oil starvation issues in any form was that there just wasn't oil at the pump. I mean, when you're getting a problem like that, and it's weird because sometimes it's at the pump. If the oil pump is on the rear cylinder or whatever. I've seen big block Chevys that, you'd think that if it had an oiling issue, that number 7, 8 in the rear main, it would get smoked or whatever, and it'll take up or you'd think the front one would and the rear one wouldn't.
Right, farthest away.
First one in line.
Yep.
But then those, 7 and 8 and the rear main are the ones that are wiped out. And I can't even figure that out. The rear main's twice as wide. You'd think it'd have, not twice as wide, but you think the physical load would be less. And the same thing with some of these Fords that are loading oil into the front and go all the way to the back. And then it takes out number 7 for no reason, but it takes out number 1 for no reason. So it's almost like there's no real rhyme or reason sometimes to why starvation issues take out particular bearings. And that could be, though, that maybe those were the critical cylinders. Maybe they were the ones that there was an alignment issue with that bore, and that cylinder was kicked to the left and it was firing a little early, and that pushed it into detonation, and it just grabbed the the low-hanging fruit, which would be the weakest of the cylinders. So,
Well, it was a theory I read on a long time ago, and I thought I'd throw it at you in tonight's show. But it was, it made sense. I mean, of course, like you said, there's no rhyme or reason. But it just kind of thought, okay, if these aren't trued up and the blocks aren't ready, it's going to spin off.
Yeah, I don't know. As long as I've been doing this, I've heard so many of, I don't even want to call them wives' tales, because you see something enough times and you begin to accept it as fact. But then you'll see something that totally just goes against what the known is, per se. So it's just kind of a crapshoot. I mean, oiling on a lot of these older engines it always became an issue when they started modifying them, because a lot of these oiling systems, they didn't design a 350 Olds to make, or a 350 Buick, say, to make 600 horsepower. Mm-hmm. But now you can buy cylinder heads for that engine. You can buy custom pistons. So that engine really never had, its architecture never took into consideration tripling its output.
And priority oiling and extra webbing. Yeah. There's a lot of whole mods that a non-OE block does that factories just never did. Right.
Well, and they derived all that from the factory weaknesses. I mean, splayed mains, things like that. They definitely did. They learned from the experience and the agony of others' defeat, I guess.
Mm-hmm. Okay, let's shift gear a little. Have you seen the new Chevrolet 1000 632 10.2 block out? Have you seen pictures of that?
Yeah, I've seen pictures of it, but I'm not familiar at all with it. I don't even know what they're using for cylinder heads or anything on it.
Okay, as GM Performance has rolled out this new holy grail of 632. It is a 10.2 block. It is cast iron, and it's kind of a nice piece. So for the guy who wants to be the weekend warrior to get 1,000 horse out of a car, break it and take it to the GM dealer and say, put another motor in there. What do you think about this block? Because, I mean, hey, we can spend a lot of time building a block and spend a lot more than they're asking for this motor. Or we can just toss one in and have a couple of them, and in 20 minutes you're racing again.
I think it definitely is good for the industry, because it's just a matter of time till people just decide to peel into them and see how much power they'll really make. So, I mean, it's a great collection of parts. There's going to be guys out there that are getting 1,300 horse out of it at some point.
Right, you spray it.
Probably not even, I mean, if that thing's got some, incredible cylinder head that someone can do a lot more work to, I mean, there's probably a lot more power on tap. I mean, GM has to warranty the thing, so I'm sure they didn't stretch it to a limit of its life,
Right.
But, the engine block, I'm sure, is a quality piece. I mean, the bow tie blocks have always been really good. The early ones were not really incredible, but the later Gen 5, Gen 6 bow ties, they got them in offshore boats running 6,500 RPM, 6,000 RPM. Up against rev limiters, crashing through waves, and they live. So,
and you got to wonder the timing of this. So, LS is the new wave of everybody's stuff. 2,000 horse, 2,500 horse. They're squeezing, they're popping them, and this is all in a 6.2 format with the crankweight tucked up inside the side irons. But why would Chevrolet now, after all the years, decide that, hey, we should probably make a 10.2 block making 1,000 horse? Why now?
it's so perplexing. But the thing is, right now, it couldn't be a better time, in my opinion, because we're having big problems getting aftermarket blocks. We're having huge problems getting crankshafts, connecting rods. Suppliers are, weeks and months behind. We just got a block in. Took 20 months to get it. It was another aftermarket Chrysler block, and it was just because of some reorganization in the company, labor shortage, huge problem. So if you think about it, it's why better, what better time than now, and I think it'll probably be a hit. I mean, it's one of those things where, to build 1,000 horsepower, if you are dealing with someone who's done it a bunch of times, and you go down to Frank Beck and Beck Racing Engine to tell Frank, I'm a 1,000 horse engine, fuel injected, put it in my street run, pound the hell out of it. He's going to build it. He builds them all the time.
Mm-hmm.
But Middle America, farmland USA, a guy who's well-to-do farmer who wants to put together some sort of a
1,000 horse grain truck,
street rod, whatever. He's probably not going to be able to find that engine builder in his backyard.
Right. So order one up from the local GM shop and pow.
Right. They'd probably install it for him.
Oh, there's that.
I think it's a good time. It's they're definitely capitalizing on the shortages and everything by making the thing available. I think though that they should also make all the individual parts available so someone can pick and choose and not buy it as a crate engine, but as a kit engine, so they can substitute, put their own camshaft in.
Mm-hmm.
Guy might want to buy the cylinder heads bare, and do his own valve job, do his own porting, and that way the local builder can really shine on something like that too. So,
mm-hmm.
And no warranty on GM's part, but
certainly not.
Can you imagine buying an engine and having to get an extended warranty and having a car payment on an engine? I mean, a GMAC probably are right alone on it.
Well, we get those calls in the middle of the afternoon. We're with your warranty company. Can you verify your car?
Right.
No, I can't.
I say, it's a 1970, and they go, oh, no.
I just had one of those today. Can you verify your car? Well, wait a minute. Your voicemail said that my warranty's done and I should call you, or you should press 1 to go through. If you knew who I was, why wouldn't you just know my car?
Yeah, why aren't you giving me that information?
I get thank you, sir. This is not going to happen. Thank you. But I'm kind of excited to see this 1,000 horse big block. And again, the timing for me is like, you had many years to do this. And now that the revolution for the LSs has taken over, here it is, pow. I don't know. I can't get it. I can't get through my head. Why would you wait so long?
Well, and because really, I think the biggest, GM has made that 572 with the Edelbrock heads.
For years.
A few deals like that. It started with the LS6, LS7. You could always buy crate engines back in the day, 350 horse, 327, things like that.
Mm-hmm, mm-hmm.
This thing. I mean, my hopes for this, though, like I said, can you imagine if Engine Masters had a GM crate motor competition and they had an actual class for this, where the best of the best guys across the country dig into them and build them. You got the Kazis and you got these guys that are putting together stellar, weird engines for this competition to be able to have the same platform as everyone else. And really showcase what they can do. And the only stipulation is it's just got to run on this fuel that we supply. You have to use the factory parts that are there, the intake, the injection system, everything. You can do whatever you want to it. But that's where you're going to see these guys make 1,300 plus with them. They're going to find it in there.
Oh, I wouldn't doubt it. I wouldn't doubt it in the least bit.
Well, now consider, it wasn't that many years ago that a pretty healthy pro stock engine was 1,300 horse.
Right.
So, that's the options are really limitless there.
Now you spray it and maybe supercharge it, or holy cow, you're talking 2,000 horse in a blink of an eye.
Oh yeah. That's when probably you have to start digging in and changing main caps and bigger cam tunnel, and definitely beefing up the valve train.
Right. Right.
But it's only a matter of time. It's only a matter of time till that trickles down. Till 6 guys show up with these 1,000 horse 632s, and the one guy is going to have to make more power than the rest of them.
Oh yeah.
And then the next guy is going to have to make more power than him. So
Eventually, you're going to go till pop, and then they all got to start over.
Oh, they'll find the limit. There's no doubt about it. I mean, they're doing it already with the Hemis and the Hellcats and stuff like that. And what's the aftermarket doing? They're responding. They're coming up with aftermarket blocks and things for them.
It's going to be an exciting time, like you said. I when I saw that come out, I thought, I got to dig into this. You can't get information. I mean, it's just a hype right now. But here's what people aren't really getting. We ordered an LT5 for a customer's car. Are you familiar with the LT5 6.2 Corvette with the outside oiling?
No, I haven't seen any of those at all.
Okay, so great, I can get this part, but I can't get this part. And this part's on national back order. And this part's going to be 8 months from now. This part's going to be 6 months from now. Okay, you might have them out into the world of here's our magic stuff, but you don't really have them. So GM's having a hard time getting computers right now.
Yeah. Yep.
So, go ahead.
Is this going to drive some people back into doing more old school builds because of the frustration? I don't know.
Well, that's a 632 with a 10.2 block they just released. What does that tell us?
Well, yeah, but short of it has electronic fuel injection, but that's easy.
Oh no, it's on there. That's on there.
2 Dominators on it, right? But you wouldn't need it.
Oh, right.
It's just a matter of time till someone retrofits Dominators in the sheet metal intake.
Mm-hmm.
But I think that we're in an interesting time as well, that they do things like that. The GM comes out with that at such an unpopular time for anything that is a blatant gas waster to exist. I mean, it's almost like, wow, are you guys actually building electric vehicles trying to save you? I mean, this one is going to have that Greta girl just corkscrewing her way into the ground.
Yeah, because she's a pinnacle of my imagination, right?
Yeah.
I don't know. And they're starting up their EV program. Everybody's trying to do it. I don't know. There's something up, pulling up a big cam motor next to you, and here's some guy in a lawnmower with a George Jetson soundtrack. Yep.
Yeah. That's the thing. The guy's got a big block Chevy or real heavy hitter, and the guy with the V6 and the twin turbo next to him might beat him, but the 99.9% of the rest of the time, that guy still has all the glory of this big fire-breathing beast. He gets to drive it. So,
Ron, what have you got for final thoughts on this? We're running on about 20 minutes into the second segment. What do you want to tell people about blocks? I mean,
well, let's talk stock engine blocks. Let's just say, because we're seeing a lot more of them now. Obviously, there's the shortages, and some guys are just saying, you know what, let's do a mild. Let's just do a less radical build because I want to get the car on the road. I want to drive it.
Mm-hmm.
The biggest thing is, and you walk into a shop, and you don't have to go to the state-of-the-art machine shop that has every bell and every whistle and gives you a warm cup of coffee when you walk in the door. But you really have to identify with what they do and what they specialize in, and then what don't they do, and how do they source that? And that's the biggest thing. There's some shops that are the Borehome deck shops that do excellent work and nice head work, and they're able to build a nice motor. But there's a few operations they don't do, and when you flatten out a cam because the cam tunnel lifter bores wasn't done, or when you're going to assemble it, crank doesn't spin in there because they can't line hole it. It's not time to find that stuff out. You have to do some due diligence. You have to maybe get a couple people involved. A lot of shops have those people in place. If you go in there as an informed customer and say, here's what I want to build, 600 horse big block. I want to do some $10,000, $12,000 engine, but I want it to be very reliable. Well, then they should be looking into every blueprint operation and really maximizing, every resource to make that thing live. This is a guy who wants to drive from, here to Tennessee to go drive it around in the mountains,
Sure.
And you can accommodate that guy, but it's the shops that don't want to address some of these things because they can't do them in-house may not be looking out for the customer's best interest. And if the customer knows enough to ask for it, and a shop says, oh, well, now that you asked, yeah, we can have that done. We don't normally offer that. People generally don't understand it, but when you're asking about it, yeah, we can do it. I mean, we battled that 30 years ago. I bought a crank balancer because we were sending it out. It was just taking too long, costing too much. I would have rather done it myself, and I didn't have anywhere to do it. I was using a balancer that I could no longer get access to, so I bought one. And I would get guys that kind of fought me on it. They'd be like, well, my last guy or this guy said, or so-and-so said, you don't need to balance it. And I'd always ask them and say, well, if you wanted them to do it, could they do it? Because I bet they can't. I bet their agenda is more that because they can't do it, they don't think it needs to be done versus whether it really needs to be done. So, and that goes the same with every other operation. We do not grind crankshafts, but if I have a crank that comes in with a half-bell run out or an issue I don't like, I'm not going to just skip it because we can't do it. I send it to a professional crank shop.
Right.
That's a business in itself. So, cylinder head work. I mean, we do a lot of cylinder head work, but when it comes to doing, major port reconstruction and, really maximizing some sort of cylinder head, I'm going to call Jason Anderson. I'm not going to do it myself.
Mm-hmm.
He's going to put the map to it. He's going to whip out the calculator. He's got the flow bench, and he's going to make that head work, and they do every time. So you got to kind of know your shop, what they can do and what you might need to resource somewhere else. And, you can do an excellent build. I mean, we do machine work for guys that, don't do any machine work, and they're building some of the best engines out there because, they're resourcing the stuff properly.
Right,
so
right.
That's a big deal.
Well, we do limited, but we ain't doing what you guys do, and we know where to call when we get certain things done.
Well, you know what to tell us, though. That's the thing. Exactly. When you say we want the deck height to be this, we want the piston to wall clearance to be that, we want the cylinder wall finish to be this, we work together on that stuff, but what needs to be done. So, that's 99% of it right there.
Well, sometimes we do. We were having a discussion the other day about cylinder wall head gasket ring clearance, a fire ring, and I just went, well, let's go, 10,000 on square or on pi.
Oh, well, the bore to the gasket. Yeah. Yeah. And, that's something that, if the two heads aren't together on that one, you might get a machine shop that's going to go in and chamfer the top of that deck, and put a big 30,000 chamfer on it, and all of a sudden the gasket's hanging into the board because the guy who's cutting the deck and chamfering that bore isn't talking to the guy who's putting the gasket on. So,
and I will certainly measure those. Once you're done with that, I'll measure those and make sure I order the gasket with the proper ring size.
Yeah. I mean, that type of stuff, we can do anything. The guy says, put a 30,000 chamfer on the top. We can do that. That's, we don't, again, we're not doing it with some fancy CNC machine. We go down, touch the bit, and zero the DRO on the gauge, and go down 30,000.
There we go. Right.
Whatever you want, it's not a big deal.
Okay, we are 25:10 into this second segment, and maybe next time, if you got time, we'll talk about lifter oiling, because you brought that up tonight, and I thought, full-time oiling versus part-time oiling. The old Chrysler 500s would bank oil, is depending on where the cam rotated.
Yep.
What's the benefit versus part-time versus full-time oiling? Now, again, we just finished the 540 block, and at idle, we're running about 7, 8, 10 pounds of oil. You sneeze on the throttle. I mean, it just comes off that, and we're at 70 right now. Of course, the guy thinks, hey, there's a problem. Me and you have had this discussion. I don't believe there's a problem. The top end of this oil, while it's running, is just flowing through the lifters, push rods. And maybe that's what he's seeing. And, of course, he's got a Titan pump in there, so it's top-shelf stuff. But
well, it very well could be. There, basically, the coil pumps don't create pressure; they create volume, and then pressure is a byproduct of the resistance to volume. So, if that engine has, we'll say, a metered controlled oil leak, which is like your feed to the lifters and stuff. Generally, what that is what it is. I mean, if you've got lifter to bore clearance, which is 2 thou, and that feeds the little feed in the side of the lifter, and that's what shoots up the push rod.
Mm-hmm.
That's going to leak a certain amount. It's going to feed a certain amount. And even if that's engine spinning 7,000 RPM, you're not putting out, 7 times the oil volume that it did at, 1,000 RPM.
Mm-hmm.
Because it's still, it's more, but it's not 7 times more because you've only got that 2 thou clearance it has to push that oil through. So,
more of a logarithmic value.
Yeah. It's not,
linear.
It's not a well, what am I thinking? The word, it's not linear, or not exponential, or it's not a linear equation.
It's logarithmic.
Negatively. Yeah. So, oil, basically oil pressure. I mean, you're just looking to form a controlled leak is what you're trying to do. You're controlling how much you feed into the rods, how much you feed into the cam, how much you feed into the mains, each lifter bore. So that's where the full-time oiling, you mentioned, like the Mopar that has the hole in the cam, oils one side, oils the other side, oils one side, oils the other side. Well, if we were to just plug them off all together and put in a groove, 20 thou wide or 50 thou wide groove, 10 or 20 thou deep, it's going to deliver I would say a pretty continuous supply of oil once that thing hits 50 psi, regardless of what the RPM of the engine's at.
Uh-huh.
It's only seeing 50 psi. So, that's just one of the ways. There's ways you can restrict it at the actual deck surface. Forge, you can restrict them at the rocker shaft by dropping a Holly main jet in there.
Okay.
Any number of ways of restricting and controlling. But we should probably discuss more about some of the particulars as far as not only the lifter oiling and everything, but each particular lifter, the oiling location of the hole, the feed hole, how it draws its oil, because there's a lot of lifter manufacturers now that they want you to put a little slot from the oiling feed hole to the body of the lifter, but that's assuming that the body's getting direct oil. Sometimes the bodies are just pulling oil from the orifice or the area around the lifter of the bore too. So that little slot wouldn't really do anything. But
maybe we should call in BAM lifters. Now, I ordered 3 sets for those 3 632s that you got machining now. Mm-hmm. Maybe we should put a 3-way on with us, you, and BAM and say, hey, this is what we're seeing during the oiling / lifter version. Yep.
Yeah, and I've talked to Brad about that, about the position of the oiling hole and where the ingress for the oiling should be on the actual lifter bushing when you do it that way to supply, because of the lifter obviously has more pressure on one side than the other, and it has another job to do, which is oil the top ends, the lifter bore for the bushing. So, he's given me some data on that. We've changed a few things of how we do them, is how we feed the oil. I've been talking to him. So it's been really helpful. So,
well, talk to Brad and see if he wants to be on the show for the next version, if you want to get him in on this.
Yeah, I'll see if he wouldn't have anything to input too, as far as the bush lifter, the DLC lifter, the needle bearing lifter. He's always good for good information and question answering. Brad worked at Crane for 20 some years, so he was very well versed in lifters, camshaft, and problem solving.
Well, when we get to the valves and rockers and springs, I'm going to see if I can get Billy Goldblood to come on.
Oh, sure.
That'd be a good conversation. I got I know him from the old Cams days, and I thought that'd be a nice deal. Okay.
Yep. And he would probably also have a lot of input on some of the issues that we're seeing as far as cam and lifter failures. It's just getting back to, like we've talked before about like Ken Ellingson with his his issues and what his theories are on a lot of the cam and lifter failures, and how things didn't fail before, and using the same machining protocols, they're failing now. I mean, not him, but within the industry,
Right.
And he's got super valid points too, as well as the why, and some of it does coincide with lifters being imported, things like that. So, there's definitely some good information out there, and from my perspective of it, has always been to cover all your bases.
Yep.
I mean, it's not a matter of a lot of these guys are, this engine's just a 500 horse engine, just a 400 horse engine. Why do we need to do this? Why do we need to do that? Because it's a no horse engine when it fails.
Yep, zero.
And it's always going to cost you more to do it twice than it is to do it once the right way. Just the simplest thing. I mean, if we're going to do you take an engine with, a cam tunnel that's within a spec that you can deal with, and you go and just do the lifter bores. I mean, if it's a $300-400 job to index the lifter bores, but it gives you a bigger lifter for one.
Right.
But if it stops a problem that could take that engine down, man, that's cheap insurance. That's just, that's just, 20% of the cost of what it's going to cost to tear a whole engine apart. rehone it, knock the pistons off, hone them because there's metal all over it, every part of the engine. So
downtime, cleaning it up, pulling it back out of the car. Oh, who wants to go through that?
Yeah, not to mention the elbows on the fenders of pulling one in and out. I mean, look at some of these guys with, $40, $50, $60,000 paint and body jobs.
Yes.
Pull an engine back out.
That's the last thing we want to do.
Right.
We look at that paint going, I don't care how much. We use bruise tape. We use padded fenders with wool shampoo, all kinds of stuff. And we were so paranoid. And no matter how careful you are, you think you got her, and it's that last little thing.
Yeah. It's the guy putting your vinyl top on that cuts right through your paint.
Have that T-shirt. Well, Ron,
wearing it right now.
We are 33 minutes into this segment, and I think we got to pull the pin at this point. I appreciate you coming on the show and giving some information. If you reach out to Brad, that would be a good conversation, and I'll reach out to Billy Goldblood from CompCams. And sure. We want to thank you for coming on the show again. And people have been asking about you. People out there have been great. What a warm reception to all the engine builders and all the guys who do this for a living. Thank you for listening to the first show. And you asked for this, so we're going to give you another show. All right, for HuttCast.
And if people have questions, fire them off to you. We can address things. Right square in the face if someone has a how or a why.
Well, why not? I mean, it'll be recorded, but it won't be live. You'll have to catch it.
Right. But I mean, if someone just posts a question, or they shoot them off to me here and there on Facebook Messenger and things like that, and I answer them the best I can. But on any platform, if somebody's got things that they don't understand or something they've experienced that maybe if we can explain or look into to help others, there's so many times that there's wholesale problems out there that you and I may not see.
Right.
The cam bucket issues that for Volkswagens that the cam blows right through. I mean, that's a good thing to throw out there, for these guys to understand these parts exist. So if people can. I don't know if you have a format that allows that as far as people to give them direct feedback to these things.
Well, they can certainly get to the show, and they have plenty of access to us.
Yeah, questions are good. We like questions. We post our videos, and I encourage people, treat it like a Q&A. I don't care.
Right. And again, with the kind of experience you have, we need that. The industry needs that. So.
Yeah, for the industry to keep going, it definitely needs that.
All right. Well, we're going to pull the pin at 3440. Ron, thank you for showing up on the show tonight, taking your time and volunteering this information.
Yeah, thank you. We'll talk soon.
Okay, for HuttCast, we're going to pull the pin. Have a great night. We'll catch you soon. And that's a wrap for HuttCast. HuttCast is, again, a pragmatic approach to seeing things how some people see them. If you like our show, give us a thumbs up on the Facebook site. Again, for HuttCast, thank you again. Have a wonderful evening.